In this video, I'm going to look at several differential equation FRQs from the last couple of years. They've gotten a little bit more involved, and I don't think they're necessarily harder. They're just more things that they've been asking the last couple of years. And a lot of these things didn't come up in the book, but a lot of these things are topics that came up earlier in the year in other parts of the course. So again, it's not like stuff we've never seen. We just may not have seen this in differential equation problems. Okay, so part A, hopefully pretty straightforward. Part A is asking you to sketch a slope field for the differential equation at the 6 points indicated. I don't think I'm going to go through all of these, but remember that a differential equation is, you've got a dy dx equation there. It's literally an equation for the slope at a particular point. And so you're really saying, I'm going to take the y value squared and I'm going to divide by the x value minus 1, and that'll tell me the slope at that point. And the idea is if you draw a bunch of those slopes, you can kind of see if the graph passed through a particular point, how it might be sloped. So I usually do show a little bit of work here. They don't require it, but I think it's a good idea so the grader knows that you know what you're doing, especially if you don't make your marks very carefully. So, you pick a point, and if we go down here and look, we've got points like 0, 0, that sort of thing. So let me try this first with the point 0, 0. So I'm going to take the y value squared, okay, and I'm going to divide by the x value minus 1. And that gives me 0 over negative 1, which is equal to 0, okay? Remember, you go to that point, so you go to the point 0, 0, and you plot a little line segment that has a slope of 0. Maybe draw something that looks a little bit like that. But I like the grader to be able to see that I knew what I was doing, okay? You're trying to convince them you know what you're doing. Let's try the point 1, 1. Okay, so for the point 1, 1, it says take the y value squared. Okay, so that would be 1 squared divided by the x value minus 1. Okay, so the x value is, 1, 1 is not one of the points. Okay, the reason it's not one of the points, notice we get 1 over 0, which is undefined, which means typically you just don't draw a point there. I guess you could draw a vertical segment. Anyway, let's try one that was actually listed. Let's try 2, 1. Okay, so 2, 1, the formula says take the y value squared and divide by the x value minus 1, and that's going to equal, the y value is 1, and the x value minus 1 is 1. 1 over 1 is going to be a slope of 1, and so I'll go to the point 1, 1, and a line with the slope of 1 might look about like that. Now be careful with positives and negatives. Very easy to make some kind of careless mistake. All right, let's go on to the next part. Not shockingly, so anyway, if you wanted to see it here, here's the full solution. It would look like this. You see you get 2 points for that. They usually kind of break it up into groups, and they'll give points for different parts. So anyway, that's what's going on in part 1. All right, part 2. Part 2 asks you to, this is interesting. Notice it doesn't actually say to find the particular solution. They're just saying if there's a particular solution, the functional value at 2 would be equal to 3. Then they ask you to write the equation for a tangent line to the graph at the point where x is equal to 2. Use that to approximate f of 2.1, okay? I don't think we've seen this in one of these problems yet, or at least we haven't seen it very much. So let's review a little bit. Remember earlier in the year, if we had a curve, and you knew a value of a function right here. Say this was the point 2, 3, okay? So imagine that we knew what the particular solution looked like, which we don't. But if we did, let's say it looked like this, and you've got one point. If you've got the equation of the tangent line to a point, for example, I could estimate the value of the function for an x value of like 2.1 or 2.2 or something. The point on the line is really close to the point on the curve, okay? And so for values very close to a value of x, you can get pretty good estimates using the straight line equation, which is pretty easy to write, even if you don't know the actual equation of the function. Okay, so this is basically an estimation method. Remember, you write the equation of a line using point-slope form. Y minus y1 is equal to m times x minus x1. Okay, on a typical AP exam, you're going to use this 3-4 times. So make sure you know that. Remember, you just need a slope and you just need a point. Well, they gave us a point, right? And the slope would be a derivative. So it should be really easy to fill all this in. Let's go here. So I would probably write down point slope form. Y minus y1 is equal to m times x minus x1. They gave me a point there. They said the point is 2, 3. So when x is 2, y is 3. And I just need to find the slope. Okay, well, the slope is a derivative at the point 2, 3. Well, they gave me the derivative equation up here, so I don't even have to take a derivative or anything. It's going to be the y-coordinate squared, which is going to be 9, right? Divided by, or maybe you want to show your work here. The y-coordinate squared divided by the x-coordinate minus 1, and we end up with the slope of 9. Okay, so your final equation here is going to be y minus 3 is equal to 9 times x minus 2. Now, they want us to actually make an estimate. You don't have to necessarily put this in slope-intercept form. You don't have to multiply this out. In fact, in a second, you're going to see why. I would, however, move the 3 to the other side. I'd probably write this as y equals 9 times the quantity x minus 2. I'd add 3 to both sides and write it like this. Okay, again, this is fine. You don't have to simplify things on the AP exam, but I think this is going to be more usable. Okay, now they want us to estimate f of 2.1, and you'll notice this isn't a calculator problem. Or maybe you want to call this f of x equals 9 times x minus 2 plus 3. Anyway, to find f of 2.1, all I've got to do is substitute 2.1 into this function. So it's going to be 9 times 2.1 minus 2 plus 3. Well, check this out. This is a non-calculator problem. If you leave it factored, 2.1 minus 2 is 0.1, okay? 9 times 0.1 plus 3 would be equal to 3.9, okay? And that's your estimated value. We're estimating that f of 2.1 is approximately 3.9 is what ends up happening here, okay? And again, if you take a look over here, you can see the scoring here. There's our equation for our line. Guess what? We've already got another 2 points. You're already at a passing level on this problem if you got those first 2 parts right, okay? So I love these differential equation problems because you can get a lot of points very quickly. All right, part C. Now, they do ask you to find the particular solution here, okay? So we're going to have to separate variables and solve. If you go back and look at the original equation, we want the y squared off this side. So we'll multiply both sides by dx. Just going to write it in up here. And then we're going to have to divide by y squared on both sides to get the y squared to the other side. Remember, everything should be done with multiplication and division. So you're going to end up with 1 over y squared dy is equal to 1 over x minus 1 dx, okay? Make sure you show you're actually taking an integral here. So make sure you show that you're taking the integral of both sides. Remember that negative exponents are only good for one thing, taking derivatives and integrals. Maybe that's 2 things. So I would probably rewrite that as y to the negative 2, okay, and then you apply the power rule. Raise the power by 1, divide by the new power. That'll give you negative y to the negative 1, okay? We've got a reciprocal on this side. Notice the derivative of the inside function is 1, so we don't have to worry about the chain rule here. It's an absolute natural log of the absolute value of x minus 1. Cannot stress enough, make sure you have that plus c there. Okay, if you leave off that plus c, basically everything else in the problem you're not going to be able to do. Okay, now you're going to have to decide when you substitute. Okay, you can substitute now or you can try to solve for y. I think in most cases it's going to be easier to substitute now. We know that f of 2 is supposed to be equal to 3. So I put in 2 for x, I'm supposed to get back a 3 for y. Negative exponents, though, are bad for evaluating. I would probably rewrite this as negative 1 over y is equal to ln of x minus 1 plus c. Okay, and we can go ahead, we can put in 2 for x, we can put in 3 for y. And what we end up here is negative 1/3 is equal to, notice over here, that's just natural log of 1, okay? Make sure you know the natural log function looks like this, crosses the x-axis at x equals 1. So ln of 1, you're saying e to the 0 power is equal to 1 is what you're really saying there. So anyway, natural log of 1 is just equal to 0. 0 plus c is equal to c. There's our c value, okay? We probably already got most of the points in this problem. Anyway, to close this out, I'm running out of space on my paper here, so I'm going to continue this up here. So what we've got here is we have negative 1 over y is equal to the ln of x minus 1 plus, and we now know what c is. C is negative 1/3, so I'll say minus 1/3. And we just need to solve for y here. Don't want it to be negative, so multiply both sides by negative 1. You get 1 over y is equal to negative ln of x minus 1 plus 1/3. Okay, and then I want the reciprocal, so why don't we just take the reciprocal of both sides? You're technically taking both sides to the negative 1 power, and that's going to give you y equals 1 over negative ln of the absolute value of x minus 1 plus 1/3. And again, you could multiply the top and the bottom by 3 to try to get rid of that fraction, but they don't ask you to simplify things on the AP exam for your response, so you don't really have to worry about it there. Let's go look at their scoring. So notice there are a lot of points tied up in this question. So let's look at their scoring. You get a point for separating variables. Okay, that looks good. Your antiderivatives, you get a point for that. So you're already up to 7 out of 9, just if you get to that point. That's all very straightforward, okay? Just having the C and trying to solve for C gets you another point, and then actually finishing it out for Y gets you your last point. So, ton of points there. Okay. By the way, they do make the point here, natural log's not defined for 0 or negative values. So you really should note that it can't be equal to, that x minus 1 can't be equal to other values in there, although they didn't assign points for that. But notice, if you don't have the C value in there, you can only get 3 out of 5. Okay, if you don't separate variables, you get nothing on this part of the problem. Okay, so really, really important that you go through the process carefully and practice. But these get very predictable after you've done a few.